Hey, it's working. I guess it must be after sunset. My automated seed starting tower, step 1, is complete. I'll show you how it works. I didn't want to mess with cutting wires and splicing them into a relay, so I got this on Amazon. It's an IOT Relay. And basically it's a power strip that you can control with a Raspberry Pi. It has outlets that are normally off, normally on, and then this one that you can't see is always on. So this one is where the Raspberry Pi is plugged into, so it will always have power as soon as this thing is plugged in and turned on. There's a spot for 2 wires to go in, one is positive and one is ground. And when it detects that you've sent a high voltage, higher than ground, to the switch, it activates these outlets. So the ones that are normally off become on, the ones that are normally on become off. And the always on stays on. So I've got a blue wire here and a yellow wire, and you can see my Raspberry Pi sitting up here. I've got this ribbon cable that puts it into a breadboard, but it's not really important. But you can see blue going to ground, yellow going to pin 5, and then there's just a jumper there from ground to the ground rail. And that's all it is. So basically 2 wires into the Raspberry Pi, and then I'll show you the code that makes this work. So this is the basic structure of the code that's running on the Raspberry Pi. I have an API service that exposes endpoints to get the status of the lights, to turn the lights on, to turn the lights off, and then get any light telemetry. And then over top of that API, I have a cron job that runs every 5 minutes. It checks on the internet to see when the sunrise and sunset times are based on my location. It decides should the lights be on, which would be up to 30 minutes after sunrise and 30 minutes before sunset. And if it decides the light should be on, it turns them on, and if not, then it turns them off. I'll put a link to the GitHub repo in the description below, but this is the code for the server that runs on the back end. You can see it has a SQLite database that it creates to maintain telemetry on whether the lights are on or off. It has a light events table, and it just, when you turn the lights on, it essentially sends the pin that the lights are on, pin 5, like we showed it wired up. It sends that to high and it turns the lights on. So that's all it takes to activate that relay. And this code is just tracking, not only providing that interface to turn it on and off, but also tracking when it goes on and off so that I can get a report how much light was shining when the plants were growing. So that's the API service that's here. And then we have the cron job that uses the API service, and there's not much to that. It just checks to see whether the light should be on, and this runs every 5 minutes. That's all there is to it. I just wanted to show you one other thing, which is this is the interface. I'm using curl requests here to turn the lights on and off, and then I fetch the telemetry, and you can see I have a log of is it on right now? No. So that it's not telling you that it's been on for any amount of time because it's not turned on right now. And then here are the events and the time between them. So there was an off event, an on event, and that's how long the lights were on. That's pretty much it. So if I was going to do this with a normal relay without using that IoT relay, I would have to cut the wires on the lights, or at least one of the lights, and wire it into the relay. If you've ever used a relay, you're talking about a circuit board that you have to control yourself. It operates on the same principle as the IoT relay, so the code would essentially be the same. The difference is that you're cutting into the wires, and so you're taking your perfectly good lights and you're splicing or cutting at least one of the wires of the 2 that go from the plug to the light, and then you'd wire that each side of that cut into the relay and use that to turn the lights on and off. I didn't want to do that. These are perfectly good lights. I'm going to also be using those heater pads that you saw in the video, and I I just don't want to mess up those cords just for this project. So the IoT relay is a little more expensive than using a regular relay, but I think it's safer to not have high voltage that you've spliced yourself into a circuit board. So I will be using a regular relay for the water pumps, but for the heating pads and the lights that have a perfectly good plug on them on the end, I'm going to use the IoT relay. I think it works great. It's super easy to set up, and so I've actually ordered another one for those heating pads, and I'll be using that for those as well. So that's the IoT relay, probably about the simplest thing that you can control with the Raspberry Pi. If you have something that will turn on when it gets power, then it's great for that.